Okay, sorry for the slight delay, but we are so grateful to have you all here today. As people are still coming in, there are seats in the front, a few in the middle. I think there should be a seat for everybody, and thanks for being here today. Welcome to FUTURES Taipei 2024. Since we have over 150 additional guests joining this afternoon, please let me introduce myself again. My name is Patty Morin, and I've been working with IOWN Global Forum since the founding phase in 2019. It is truly my honor to serve as your MC today in front of the largest audience the forum has seen since starting 4 years ago. With such a large audience, we kindly ask everyone to be considerate of one another to ensure a positive experience for all. Thank you for being here today. We have a fantastic agenda ahead, made up of experts from here in Taiwan and the forum's global membership. I'm eager to hand the stage over to them, as I'm sure all of you are, but please let me just go ahead and do that now then. So today we will envision a photonics-driven future of next-generation communications and infrastructure technology, and learn how it is and will impact business strategy and innovation. Let us begin.
A world with minimal energy consumption. The answer to climate change. Create another world. The other me is there. An infrastructure that self-evolves. We can have control over our time. All future paths can be predicted. We can transcend our human potential. IOWN Global Forum. The next evolution, the next world.
Hello everyone, I'm Katsuhiko Kawazue, CTO of NTT Corporation and also President and Chairperson of the IOWN Global Forum. Thank you very much for coming to the Futures. I hope you will learn more about the IOWN Global Forum through today's Futures. We are now facing many crises, such as COVID-19, climate change, natural disasters, and divided world. But we cannot solve this heavy problem as soon as possible. The reason why is our technology is not enough, I think. We cannot forecast and solve this problems. So we have to enhance ICT technologies more and more. Looking back through recent history, industry's emphasis has shifted from quality to quantity. And now the real space will merge with the virtual space, and value will become more important. That is friendly to each culture, people, and the earth. A new communication infrastructure more closely linking the real and virtual is needed. This is a big challenge. But now internet traffic is growing exponentially. Therefore, a lot of computers are used to process large amounts of data. As a result, energy consumption is skyrocketing. On the other hand, carbon neutrality is a global goal. In short, we must achieve both economic growth and a decarbonized society. Optics has wonderful advantage compared with electricity. Even if the transmission distance or frequency increase, the power consumption barely increases. We currently use optical fiber for transmission. On the other hand, it has been difficult to apply optical technology to information processing for a long time. But in 2019, we finally succeeded to invent the world's first optical transistor. This innovation was the origin of IOWN. IOWN stands for Innovative Optical and Wireless Network. We, the IOWN Global Forum, aspire breakthrough innovation beyond limitation by IOWN. IOWN is a next-generation optical-based communication and computing infrastructure and consists of a variety of technology elements. Performance advantages of IOWN are 100 times higher energy efficiency, 25 times higher transmission capacity, and 1/200th end-to-end latency. IOWN is also valuable for AI. AI has evolved tremendously in recent years. It is said that training AI model at GPT-3 scale requires about 1,300 megawatts hour of energy. This is equivalent to the energy generated by one nuclear power planet. Sustainability is a critical issue for AI evolution, I think. AI constellation powered by IOWN changes energy efficiency by connecting compact AIs specialized in a specific expertise to communicate with each other. The benefit of AI constellation is not only energy efficiency, but also leading to a better answer like human society. Most present generative AIs are singular massive AI, so they cannot deny their answers. I believe AIs should find a better answer by communicating with each other and demonstrating their own expertise. IOWN aims to enable AI to do what humans take for granted. For the latest topic about IOWN, Chuan Telecom and NTT, which are the IOWN Global Forum members, launched the world's first IOWN International APN between Taiwan and Japan on August 29th. This is an ultra-low latency network of only 17 milliseconds for about 3,000 kilometers. To realize this international APN, several pieces of network equipment compatible with OpenAPN were utilized. The IOWN Global Forum is steadily developing IOWN technologies from vision to reality. Technology will evolve. AI also evolve. How about humans? How do you think? I believe we humans should also evolve. Lastly, I'd like to introduce a new human evolution powered by IOWN. Please watch this video.
Masa, IVDJ, diagnosed with ALS in 2013. Being paralyzed did not stop his passion to continue creating music using gaze input. He endeavors, fueled with hope for the next stage. Electromyography, a subtle electricity generated when moving the muscle. We have developed a technology to sense the signal from the muscle of Masa and move his digital avatar. Though he can no longer move his arms nor feet. On the digital twin, he may regain the freedom to move. The stage for the challenge was set at Ars Electronica, the world-renowned festival of media art.
Masa joined the stage from Tokyo.
The presentation was done with cross-lingual text-to-speech technology, reproducing his voice from the past recordings in multiple languages.
Hello everyone, I'm Masa from AOS, while continuing to fight AOS in Tokyo.
Masa communicated in English with his own voice.
Dance with me. 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 Dance with me.
In the live performance, the audience enthusiastically responded,
Dance with me. Dance with me. Dance with me.
echoing his hands raised high.
I could feel I was connecting with the audience. I continue to challenge the impossible. Dance with you.
Thank you. Thank you so much. Okay, thank you. Human potential is infinity with IOWN. This concludes my presentation. Welcome. Thank you very much.
Thank you, Kawazoe-san. Now it is my honor to welcome a special guest to the stage. Mr. Der-Shin Lin is the Secretary General of the Industrial Development Administration at the Ministry of Economic Affairs and has joined us today for FUTURES Taipei 2024.
全球论坛苍天雄彦主席、中华电信研究所研究院苏院长，以及各位现场的贵宾、各位产业先进和各位女士先生，大家好。
Chairman of the IOWN Global Forum and Chief Technology Officer of Japan NTT, Mr. Kawazoe-san. President Su of Zhonghua Telecom Telecommunication Laboratories. Distinguished guests, ladies and gentlemen, good afternoon.
今天很高兴参加 FUTURES Taipei 2024的活动。
On behalf of the Industrial Development Administration under the Ministry of Economic Affairs, it is my great honor today to participate at the FUTURES Taipei 2024.
这个刚川天雄彦主席在台下跟我讲，不要太紧张。不过在他那么知识含量这么丰富的演讲后，这实在是很不容易讲。
Just now, Mr. Kawazoe-san encouraged me, saying, "Don't worry, take it easy." But after his very informative speech, it is really difficult to speak after him.
所以我会用另外一个比较庶民的语言来去讲 IOWN 在做什么。
So I would like to give an example on a more down-to-earth and a more example that happens in our daily life of what APN is about.
当我们用手机在看 NBA 或 NLB 这种国际赛事的直播的时候，大家可以想象，你看到这个画面其实是从转播站，然后把这个讯号传播到基地台，然后甚至到电信机房，然后数据中心，然后再由这边再走陆地光纤电缆到海底电缆，最后在台湾再走台湾的陆地电缆，然后再到数据中心，然后再到基地台，最后才到手机可以看到画面。
So let me give you an example. When we're watching NBA or NBL games on our phones, for all these data, it has to pass through numerous nodes, meaning that it goes all the way from the US relay stations to the base stations or telecom facilities, and then we go through the terrestrial optical cables, data centers, subsea cable landing stations, undersea optical cables, and all the way to Taiwan's landing stations, and then the land cables before reaching the remote recipient's hands.
那当然这中间大家听到很多段都有听到光纤的网络了哈。那可是在中间这个还是转换中间还是会有电子讯号和光讯号之间的传输的转换。那大家一听到转换就一定想到一件事啊，就是比较耗能，比较耗时。
And I believe that through this process, you heard me say optical or fiber many, many times about the optical. So that means the key issue for the current fiber transmission technology is that with the optical electrical conversions, that will require telecom and data center nodes, and then that also means it can create bottlenecks in the processing time, meaning that could be latencies and also very power consuming.
所以为了解决这个痛点，那日本电信龙头 NTT 就发起了这个 IOWN 这个论坛，然后他想推动是全光网络。什么全光网络？就是刚刚讲到会有电讯转号，它用全程都是光通讯来去做处理就可以把转换过程中比较耗能和耗时间的解决了就可以更快速、更节能的去做到这件事。
So in order to solve this bottleneck and this pain point, that is why NTT Japan has established the IOWN Innovative Optical Wireless Network Global Forum and to promote for the all photonics network APN. And through APN, it means that we can avoid the latency of the conversion between the electronics and with the optical fibers, and making it much faster with lower power consumption, more efficient, and with better coverage too.
好，那这个 IOWN 这个产业联盟是在2020年成立的，那非常的有企图心他们希望在2030年就能达成全部都是用全光网络来布建。然后目前大概有像晶片的制造商啦、电信业者啦，还有一些云端业者以及 ICT 业者大概有超过100家以上已经参加这个组织了。
And IOWN is established in 2020 with its very ambitious goal that the target is by 2030, we hope that there could be total coverage of APN. And right now we have more than 100 enterprises and companies join us, including the chip manufacturing developers, and we have telecom companies and also the cloud solution providers too.
那今年8月其实有一个突破性的好消息啦，那其实刚刚川田雄彦主席大概也有提到了，就是今年8月NTT 跟中华电信有个合作他们是在台日间跨海的一个海底的光纤电缆他们一起合作建立一条100G 全光网络的一个通讯。那经过测试验证以后，这刚看到大概3000公里的路程，他们大概花了 0.017 秒。那大家可能很难想象 0.017 秒是什么意义那我们刚刚有提到从纽约到台湾大概是1万公里用刚刚的传播方式大概是要1秒钟，所以可以想象以后可以速度大幅的提升。
And since the establishment, we have seen that there's been promising outcomes in the Taiwan-Japan industrial cooperation. So this August, we've also seen in the presentation, Chunghwa Telecom and Japan NTT has collaborated to establish the first 100G APN connection across the Taiwan-Japan undersea optical fiber cable. And this distance is around 3,000 kilometers long, and this transmission was successfully tested, taking only 17 milliseconds. What does that mean? 17 milliseconds is 0.017. How does it compare? We can compare from Taipei to New York. The distance is around 10,000 kilometers. That takes about 1 second. So using this new APN cable, it could go into 17 milliseconds, which is really, really amazing.
好，那我们也很期待因为有台日间合作已经有一个重要的突破，然后加上台湾在半导体以及 ICT 产业有很完整的供应链所以这次 IOWN 全球论坛第7次会员大会在台北举行，我觉得是很深具意义的。
And as Taiwan is well known for its semiconducting business and also the ICT supply chain, I believe that this time having the 7th Global Forum of IOWN to be held in Taipei has its significance.
然后我也期待刚刚讲到这个 100G 已经获得验证了，接下来大家能够一起努力往 400G 甚至到未来走到 800G 一起来努力合作。
And as the 100G cable has been tested, we hope that going forward, we would accelerate the development of 400G and 800G APN technologies going forward.
然后一起打造我们这个全光网络新的格局。
So that we can set new benchmarks and collaborate together for this new APN era to come.
好，最后我祝福这个论坛及大会圆满成功，大家身体健康，万事如意。谢谢大家。
Finally, I wish this event a great success and all attendees with good health and prosperity. Thank you very much.
Thank you, Mr. Lin. The IOWN Global Forum is so appreciative of the warm welcome we've received in Taipei, and we're really excited that we were able to bring the Futures event to Taiwan. Now I'm pleased to introduce Dr. Gonzalo Camarillo, Head of Implementation Components at Ericsson and IOWN Global Forum Marketing Steering Committee Chair, to the stage to give a short overview about the forum.
Thank you, Papi. So I'm going to give you a short introduction to the forum. The idea with this presentation is to have it as a level-setting presentation so that you can take advantage of the next presentations that will come, so you have a structure to understand, everything that will come afterwards. Okay. Yeah, everybody's having problems with the clicker today, so let's hope it works. So after Kawasoe-san's basically inspirational speech, as usual, I will be covering a couple of topics that he covered in his speech, but expanding a bit more. So as we have there, we have our Vision 2030 objectives. As we said, we were basically established around 5 years ago. We will be celebrating our 5th anniversary actually as soon as January, so very close to it. And at that point, our mission and vision was to build the communication infrastructure for the future. That's the generic mission of the IOWN Global Forum. We do that by leading transition from electronics to photonics. So the main theme of this forum is basically the transition, or the revolution, as some people would take it, between electronics and photonics. That revolution or that transition has different properties, and Kawasoe-san has those in his presentation as well. So we are basically planning to build a low consumption, high capacity, low latency network. The actual numbers that we promised to go for when we were established again 5 years ago, it was again 100-fold, 125-fold, and 200-fold. The numbers are not so important, but they are just like our guiding star in terms of properties of our network and performance of our infrastructure. So what does it mean in terms of basically more concrete properties of our approach? Our approach is data-driven. As Kawasoe-san was showing before, we are seeing an exponential increase in data on the internet and also mobile networks, both. We have several reasons for that. Video consumption, for example, higher and higher qualities. We have sensors, massive amount of sensors exchanging data between them. And in some use cases, we have AI agents. They need to exchange data between them, and that can lead actually to massive amounts of consumption. To be clear, some AI usage, they will actually reduce the bandwidth as well. Like, for example, when you have semantic compression led by AI, but certainly some AI agents, they will also contribute to the increase in network data. Our approach is also secure. So basically, when we will get to optical computing, we will be able to encrypt at much faster speeds as we do it today. And that will basically increase our capacity to protect our traffic. Not only that, but by building blueprints, explaining how technologies can be used to secure traffic, we will make sure that deployments are actually using those technologies properly. Yesterday, I was discussing with Giovanni, for example, one of the board members, that, for example, we need to understand how to apply the proper encryption, whether it's asymmetric, is symmetric, how to do key management, things like that they are not trivial, and they can lead to deployments to be much more secure by using the IOWN recommendations. When it comes to resiliency, These high-speed networks, they allow distribution of infrastructure. And that means that you will avoid basically single points of failure. So by having a distributed infrastructure, you will be more resilient in terms of, in face of problems. Sustainability. Sustainability is one of the UN goals, as we all know, and is high on the agenda. Kawasoe-san also had something to say about that in his presentation. And we actually achieve that by also distributing infrastructure. Distributing infrastructure, we will avoid these massive data centers where consumption, electricity consumption, basically energy consumption, can become a problem. And you can actually take your smaller data centers closer to renewable energy, sources of renewable energy. And by that, you are basically having a much easier way, a much sustainable way to grow in terms of scalability. And finally, this is a global effort. You will see that the IOWN Global Forum has global in its title. That means that it's not about one single geography or a market area, it's about the world. So if we are trying to build a network fabric for the world, an infrastructure, we need a global effort. That means that we have basically members from all around the world, all the market areas, and we are working with them in order to develop our specifications, recommendations, and eventually to deploy it at a worldwide level. So having said that, what are, in my opinion, the two more important or most important properties of our forum? And I would say those are also our biggest achievements so far, because they lay the foundation that we need to make IOWN deployable and successful. So it's the ways of working and our diverse membership. If I start with our ways of working, the way we work is like we start with use cases. So we start with use cases, defining what needs to be done. Then we move into extracting requirements, technical requirements from those use cases. Once we have extracted the requirements, we go ahead and basically define technical concepts or architectures. And once we have that documentation, we go and implement it in proof of concepts. And this is the secret of the IOWN Global Forum. This is an iterative process. When we are building POCs, proof of concept prototypes, we will go back and basically refine requirements, refine our specifications, refine our architecture, etc., until we are in a position to go for real deployments. And real deployments basically is our goal. So again, the goal of this forum is not to develop specifications, is to get the technology deployed and be a force for good in society at the end of the day. How does our ways of working match with the diverse membership? As you can see, we have diverse membership. Our membership is diverse. And by the way, we have 157 members. That's actually a quite high number. I'm very proud of that. And our membership is diverse in at least 3 dimensions. The first one is basically the role they have in their industries. We have user companies, research and academic institutions. We have equipment vendors. We have operators, etc. As you can see, there's a clear match between the roles that they take in their industries and the ways of working. So, for example, if you want to define use cases, you really need what we call user companies, because they are the best that understand the pain points in the industry, what can be improved, and at the end of the day, they are the only ones that they can tell us basically what it takes to deploy improvements in their own industries. And then we have basically the research and academic institutions. Here we are talking about applied research, not so much pure research, although pure research comes before, obviously. We are basically researching on how those requirements, they could be met with new technologies. And of course, you have equipment vendors that they are key for deployments, and operators, again, key to operate those networks and make them basically a reality. So there's a direct match between the ways of working, the iterative process that we have to improve our specifications, and the diverse membership, so that we have basically the expertise we need in each of the stages in the process. I think that's extremely key for the forum. I said our membership is diverse in 3 different ways. So we also have, different industry verticals. And again, that matches perfectly well, because we will be talking about different use cases, different industry verticals. Maybe it was automotive, financial industry. We need companies basically and members from all those verticals. And of course, market areas. As I said before, this is a global effort. We need companies and members from all geographies. So that's, in my opinion, the 2 most important properties of the forum, and how basically lays the foundation to contribute to the process. You may be wondering, I'm talking about industry verticals, use cases. Which use cases are we focusing on? We've been exploring a lot of them, but there's actually 3 use cases that we call early adoption use cases that they are in focus for the forum right now. And they are video production, connecting financial institutions, and remote GPUs. In addition to that, we are also considering whether mobile front haul for mobile networks could be another early adoption use case. And then I will explain what we mean by early adoption a bit later on the presentation. But at this point, just to understand that those are the use cases. And again, why it's important, our diverse membership, when it comes to the use cases. If you are thinking of applying any IOWN technology, like, for example, APN, to a particular use case, you could do it in the trivial way. You could replace whatever transport they are using by an APN and be done with that. The gains you will get with that, they will be quite limited. The way we are doing it is actually to study the use case much more in depth and then understand how we could actually create much more value for that use case, as opposed to just simply replacing a transport. So to give you an example in the video, or let's start, for example, with the financial institutions. The financial institutions use case is more about distributing infrastructure so that you can use a hybrid cloud, meaning you have private cloud, and be more resilient and more performance at the end of the day. The remote GPUs is the same thing. It's about distributing infrastructure. But many people assume that it's always about distributing infrastructure with these high-speed networks, which is not true. So, for example, the video production use case is about centralizing infrastructure. So you are able to basically, instead of using a van that goes to a concert, for example, another event, to basically centralize everything for central processing, which facilitates the use case. And the same is true for the mobile front haul use case. You need to centralize, like in a centralized run type of situations, where before you were running some workloads, close to the antenna, and now you are able to run them in a data center centrally. So again, it's not trivial how to use these technologies in the best possible way for each use case, and that's why it's so important that the IOWN Global Forum continues recruiting user companies in all verticals so that we have this edge, this expertise, and that allows us basically to create more value and to take advantage of that. Okay, good. So that much is how we work and how we operate and the advantages of the IOWN Global Forum. This is how we are structured. And as you can see, the structure actually matches perfectly the process I was explaining before. We have use cases, a working group working on use cases. We have a technology working group working on technical concepts, architectures, etc. And then we have the marketing steering committee, which I myself chair, which is basically promoting these technologies and our output. So that's the structure. And then, of course, we have the liaison working group to talk to other organizations, because when we have a technical concept, sometimes we depend on standards by other organizations, and we have fluid relationships with them. So just to conclude my presentation, as I said, this is a quick introduction to the forum. Where are we and what are the next steps? So I've been mentioning early adoption use cases before. What do we mean by that? So we are using the technology adoption lifecycle that was popularized by Jeffrey Moore in his book Crossing the Chasm some years ago in the 90s. So we have basically when a new technology basically is deployed, there's new users, and you have the early adopters at the beginning and then the early majority. And there's a chasm there that is difficult to cross, because the early adopters are usually technology enthusiasts. They like technology for the sake of technology, and they will be very happy to jump into new technologies. When we are talking about the early majority, now we are talking about pragmatists. So people that would not basically deploy a technology just because of the technology, but they are looking more into the benefits that the technology will bring. That's important because the approach that you have to target those two different target users is completely different. And as I said before, our goal is to get deployments, so we need to basically cross that chasm. At this point, we are early still in the early adopters prototypes. So again, it's not deployments yet, but they are prototypes. We will be moving into early adoption deployments very soon, commercial deployments as soon as in a few months. And then we will be basically facing the challenge of crossing that chasm to popularize our technologies as much as possible. So that's where we are. Again, early adoption proof of concept prototypes. We will be moving to early adoption deployments very soon. And then with time, our roadmap is to go into basically eventually the mass market as indicated there. Okay. With that, these are a few resources that you can see. If you want to basically get more information, get our resources, just be mindful that we are in the process of restructuring our webpage. So we will have a new look and feel as soon as next year, probably February timeframe. But anyway, you can go there. You can go to our social networks or our YouTube channel, where you can find much more information and content to understand the forum. Likewise, if you have any questions, feel free to reach out to me directly. I would be happy to answer or redirect you to whoever is best, basically positioned to answer your questions. And my call to action is that if you are wondering what's IOWN, please, stay in this event to get more information, and please join us into defining the network of the future. Thank you very much.
Thank you, Gonzalo. That was an excellent level set. And now that we are aligned with the basic knowledge of the forum, I'm pleased to hand things over to our use case working group and technology working group chairs. Katsutoshi Ito-san, our use case working group chair from Sony, will start things off. We are very behind, so go to that slide.
Okay, good afternoon. Thank you very much for joining this session. My name is Katsutoshi Ito, the chair of the use case working group, and together with Kawashima-san, the chair of technology working group, I would like to use this great opportunity to highlight what we have been doing as IOWN Global Forum in terms of use cases and in terms of proof of concept work.
Am I doing something wrong? Yes.
Okay, here. Okay. Transforming vision to reality is one of the key messages we have been sending recently, indicating that we are here to make things happen and the IOWN technology be socially implemented. As we believe the proof of concept is a key ingredient to making our vision evolving into reality, I am hoping this session gives a flavor of what we are doing. IOWN Global Forum started off with defining Vision 2030, making smarter world through the power of optical technologies. As a part of an effort to make vision reality, we define use cases, functional architecture, evaluation methodology, benchmark model, and reference implementation model, leading to POC reference, which provides assumptions and requirements for POC, and calling to conduct a POC, which is open for participation inside and outside of IOWN Global Forum. I believe POC activities plays a crucial role translating vision to reality for two reasons. One, because POC is a tool to close a gap between demanding requirements imposed by complex use cases and IOWN technology offerings. Two, because as IOWN Global Forum, POC is a tool to give us an opportunity to feedback and improve our functional architecture, reference implementation to better suit for the need of the ever-complex use cases. As of now, we are very pleased and proud to say that we have already seen 18 POCs conducted by members in and outside of IOWN Global Forum, in and outside of IOWN Global Forum community. Kawashima-san will follow up and highlight the context of POC later. But before that, I would like to spend a little bit time about the use cases that we are working on. IOWN Global Forum is categorizing use cases into two. One being what we call as the future-looking use case. We position these use cases as an enabler for the Vision 2030, making smarter world. Under the category, we have a total of 14 use cases on the table, enabling remote autonomy and prediction that are beyond human capability, enriching our society. The second category is what we call as early adoption use cases. Gonzalo briefly mentioned them already, but the early adoption use cases can be defined as use cases that can be enabled by IOWN technology, expected to be available within 2025 and 2026 timeframe. Under these use cases, we have initially selected distributed service infrastructure for financial industry, remote media production for the broadcasting industry, and the remote GPU to cope with ever-increasing GPU resource demand for AI and machine learning. And these use cases all leverage the property of all photonics network with the high bandwidth, lowest and deterministic latency, with the optical dynamic reconfigurable routing capabilities. With these use cases in mind, both use case-driven POC and the technology-level POC are being defined and executed by IOWN Global Forum. Description of the use cases are available for public under IOWN Global Forum website, and I encourage you to take a look at them and give your feedback to us, and maybe become a part of a group that works with us. Okay, this slide shows the overall structure of IOWN Global Forum's use case and technology activities leading to transform vision to reality. For the time being, I'm not going to spend time going over each of the boxes being presented here, but what differentiates IOWN Global Forum from other community is that our scope is full stack and end-to-end. Our value comes from cross-layer coordination to make the total system highly powerful and efficient. For this reason, the use case working group and technology working group are co-hosting all working group level meeting to better facilitate members' need and forming consensus to move us forward as quickly as possible toward realizing the vision to 2030. IOWN Global Forum, this is our fourth year of activity since our formation. We have issued Vision to 2030 white paper, series of use case documents, and series of functional architecture documents. We are now seeing results coming out from the various POCs and analyzing the gap toward moving us forward. Again, our aim is not to stop with documentation. Our aim is not to stop with POC. Our goal is to utilize POC activity to improve architecture, to improve the reference implementations, and even use them to find new use cases. And all in all, transforming into reality, going into the market. With that said, I now would like to pass the mic to Kashima-san, Technology Working Group Chair, to highlight on the context of the POC. Okay.
Thank you.
Thank you. So I think that Gonzalo and Ito-san have described our philosophy very well. So I'd like to explain more about our POC activities and with some specific examples in detail. So then I think you will understand the outcome, the value of our outcome. So this is a list of POC activities. We have 18 POC activities. Some are about optical transport, and some are about computing platform, and some are about data distribution, and some are about fiber sensing, and some are about for mobile networks. So we have a range of POs. We have many activities in many layers, but because this is one of our activity, what differentiates us from other consortia is our activity covers full stack and end-to-end. And one let me explain a few good achievements of our POC. So this is a POC by SK Telecom, Nokia, and HFR Networks. This is about a mobile radio access network. So, of course, the industry is now trying to make a radio access network open and disaggregated. And we have O-RAN to promote such activities. But basically, what we need is to combine the outcome of O-RAN with good front-haul infrastructure. Because in order to deploy O-RAN-based radio access network, we need to have a good optical infrastructure that allows people to deploy O-RAN radio unit quickly to the infrastructure. So combining optical transport with O-RAN architecture is very important. And that's why IOWN Global Forum is operating mobile front haul over APN proof of concept, and this is one of the achievements by SK Telecom, Nokia, and HFR Networks. And what the finding from this POC is that by replacing packet switches with optical switching, we would be reducing the energy by about more than 80%. So this is one outcome. And this is another outcome by NTT, Red Hat, and Fujitsu, and NVIDIA. So I would say this POC, data center virtualization. So I think you often hear that APN can be used to deploy this distributed data center. So data center distribution is one good use case of IOWN APN. But I would like to say that there is another use case regarding data center issue, that is data center virtualization. What I mean by that is we don't have to have data centers in urban district. Probably we can virtualize physical data centers in urban district, and instead we can power that room with suburban data centers. So what we have done here is that we deploy AI cameras in urban buildings and connect these urban cameras with AI computers in suburban data centers so that the outcome of AI cameras can be processed using energy in suburban area. So this is a good example of data center virtualization. And in terms of the technology scope, of course, many people are now developing a composable computing platform, open architecture computing platform. But basically, most of the work are concerned about the data center infrastructure inside data center. But our work is end-to-end, so edge to cloud. So we believe that computers should perform well even they are distributed over edge and cloud. And what we have proven in this POC is that with IOWN APN architecture, data processing and transferring can be streamlined at the light speed. So this is a good achievement or another achievement of IOWN Global Forum POC activities. And so let's discuss what societies can get from our POC achievement. So one is this one, dual reality value up with data center virtualization. So of course, we want to develop urban buildings with smart IT features. But at the same time, we don't want to increase the power consumption of urban areas. So what we would do is to connect such urban buildings with suburban data centers so that urban buildings can be smarter without increasing power consumption in urban areas. So this would bring a big business opportunities for reality developers. They will be able to develop urban realities with smart IT applications, and at the same time, they would have an opportunity to develop data center realities in urban or rural areas. So this is the concept of dual reality value up. So IOWN APN will create many business opportunities for reality developers. And another benefit for society is AI product development. Now, the many industries are now under competition with AI. For example, automobile or pharmaceutical or material and so on. So many companies in various industries are in strong need for AI computing facilities, but it's very hard to own AI computing facilities in their product development site. So what we propose is that let's connect enterprises' product development site with AI computing centers in urban or suburban areas, and that would help enterprises enhance their product development sites with AI computing capabilities. So countries that deploys APN would be the land for AI-based, AI-driven product development. So such countries will be able to invite many global enterprises to their lands. So in conclusion, IOWN Global Forum is an organization to develop innovative and marketable technologies. I think being marketable is very important because being just innovative would not make people accept technology risks. So technology should be innovative and marketable. So IOWN Global Forum is an organization to develop such technologies. And I think Gonzalo has already mentioned, IOWN Global Forum way is to develop truly viable and practically operable technologies through POC activities. And the outcome of POC activities will help people solve the data center problems with data center distribution and data center virtualization, and develop decarbonized smart cities with data center virtualization solution. And also we will help people develop products and services with AI. So that concludes my explanation. Thank you.
Thank you, Kawashima-san. Big thank you to Kawashima-san and Ito-san, both for your presentation today and your general leadership of the working group activities. Now we will explore the evolution of server and data center architecture, highlight the challenges posed by the AI era, and showcase how IOWN can revolutionize the industry. Please let me introduce Dr. Tao Lang, Senior Vice President of Technology at Supermicro.
Thank you. 皆さんこんにちは。大家好，午安 and good afternoon. I think that covers all, right? Supermicro joined IOWN about 3 months ago, considering a new member. But this is the first time we come to the stage. And so I wanted to play safe, just show some vision that we believe in and probably inconsistent with IOWN, and see if you agree with it. Okay. I know today there are 100-something potential members here, so I can tell you you are in the right place. Okay. My topic for today, sorry. So navigating the digital tsunami, IOWN as the lighthouse. I hope you appreciate the metaphor. A lighthouse, photonic network. Okay. Before I started, I wanted to play a short video, if you don't mind.
If your data center looks like a relic from the past, you're missing out on the AI revolution there. Let's change that. Imagine a world where data centers aren't just powerful, but also energy efficient and scalable. In the era of AI, traditional infrastructure just can't keep up. That's where IOWN's vision comes in. IOWN, or Innovative Optical and Wireless Network, is setting the stage for a new generation of data centers. Think low latency, high performance, and unprecedented power efficiency. In today's speech, Navigating the Digital Tsunami, IOWN as the Lighthouse, we dive deep into the evolution of server architecture and the unique challenges AI presents. We'll show you how IOWN can transform these challenges into opportunities. From actionable protocol networks to dynamic computing infrastructure, IOWN offers a blueprint for the future. And it's not just about theory, we're talking real, actionable steps to accelerate adoption. Join us as we explore how IOWN is redefining data center infrastructure for an AI-driven world. The future is now. Let's navigate this digital tsunami together.
Well, obviously, IOWN didn't pay me for doing this, but it's okay, because I used only 2 minutes. I found some online tool. I copy and paste my abstract of the presentation and give some instruction, and it come out this short video, just like that, effortless. I guess my point is, going forward, everybody will live in the AI world and utilize the tool you don't even know. But the problem is, compared to the past, we search using search engine, we do social media. By using AI assistant tool that will consume 10 or 20 times power that you don't even know. So what if this become norm? Everybody's spend more time and then spend more power, so the world will be in trouble, right? So let's see, when we enjoy the AI give us goods, what about the impact they create for us to the world? First of all, the power energy consumption, right? We all know the data center, especially AI data center, consume a lot of power. 15 years ago, we talking about the cloud computing and consolidation of server. We was talking about mega data center. Nowadays, the data center for AI, hundreds of megawatts per data center is everywhere. And some people are talking about giga data center or campus. And this is just on the surface. What about the hidden impact? As I mentioned, if everybody doing this AI assistant tool, it will consume a lot of power. So the impact will be a lot more worse than we imagine. Another hidden impact, for example, the water usage. The data center using water to cool down the entire system and data center. And a lot of infrastructure using water vibration, And then millions of tons of water waste because of that. And we don't even know. And this is a particular issue for the drought area, including California. And the other thing is that the copper production, right? While we are building all the infrastructure for the power, and it doesn't matter what kind of source you are using, the copper is needed. So the copper production going forward will be tripled, quadrupled for our world. For sure, it will have some impact to the environment. Okay, so we just need to be sensitive on those things and then try to avoid it. This is a research. I'm not going to go through the detail because I don't think we have much time. But a couple information maybe we should put in mind. Today we talk about data center power consumption. It's about 2 to 3% of the entire world energy consumption. By 2030, that will become 8%, which means triple of the power consumption by the data center because of the introduction of introduction of AI. So this is the chart people studied with. I think is quite conservative. In 2023, the power consumption, you can see, is tripled. Now, one thing in this research we should pay attention, I circled it, right? And it is the declining of the energy efficiency. So in the past couple of years, as we know, we're pursuing the performance full speed, right? The GPU, accelerator, everything. So the performance game is quite a lot, but we didn't put too much attention on the efficiency. So that's why you look at the line, it dropped quite a bit. If we continue using this old infrastructure without too much improvement, then it will become flat for the next few years. And it will be a waste because all the energy we consume, many are wasted. So not putting the good use for the performance for the application. So we need, obviously, technology breakthrough. So in my mind, what is the breakthrough we're talking about to bring back the efficiency game? Well, if you look at it, there are two things we can consider. One is the short-term solution, quick but not dirty, and it's a low-hanging fruit. That kind of technology exists. It's just we need to make it widely adopted. For a longer-term solution, there's a fundamental change of computing world, and that kind of technology exists today, still evolving, but we're seeing that coming in the near future. So we talk about that one by one. What is the low-hanging fruit we're talking about? Okay. Supermicro is a system company and solution company, and we believe that liquid cooling solution should be a part of the entire system design. Let me tell you why. The other thing is that all those liquid cooling solutions out there, we believe that direct-to-chip liquid cooling is the most effective way. Think about the GPU. What's the wattage today? 800 watts, some 1,000 watt, like Grace Hopper. Next year, we will see more than that. So this is a concentrated heat. Even immersive cooling might not do the trick. So direct liquid cooling is still the way to go. And why I'm saying that this has to be the responsibility of the system company. A couple of reasons, you will believe me. For one, nobody knows how to design the system more than the system company. And design the system, thermal solution is a part of it. In the past, it's simply just fan. Why not put the liquid cooling design, integrate into the system from the ground up, so that will similarly integrate the solution into the system. Rack level, same thing, right? Rack level, we do have some equipment put into the rack, and then that become plug and play in the customer's site. The other integration is the software management tool. Today, data center manager, they need to look at the system management tool and also the thermal management tool. It should be combined for ease of management. The other reason I think is even more important is the liquid cooling supply chain management, inventory, lead time issue, and the cost. So the liquid cooling company, mostly you're seeing is a small company. They have their expertise. But when they're facing the AI data center mass deployment, usually most of the time they cannot keep up. There's an inventory issue, there's a lead time, and no need to worry, no need to think about the global service from those companies. So that's one of the reasons we believe that we should take on the responsibility. We do the inventory, we do the parts design in and everything, and also the global service and support for customer have peace of mind. So with all those things, good things together, and we can seamless integrate the solution into the customer existing environment. Okay, so that's why we believe this is something we need to put on the responsibility on ourselves, and then make this widely adopted worldwide. Okay, as today it's only 2% people using this high efficient cooling solution, and we should do that. And this is a pre-config, including the liquid cooling, so truly plug and play. Over the couple years, we have deployed many AI data center, large scale, and those are the real number we calculated: 40% OPEX saving, 55% the noise reduction, and the 89% of the reduction of the power drawing from the server by the server. So those are the real number. And just this year in Computex in Taipei, we got the award of DLC, the direct-to-chip liquid cooling award, rack scale solution, and GPU server with the liquid cooling design. Okay. Now those are the low-hanging fruit I mentioned, but we should continue to evolve and then make the widely adoption of this solution. We can see the results right away. The other I mentioned is the longer-term solution. The longer-term solution will fundamentally change our computing, even the system, the rack, and then the data center design. And this kind of enablement technology not just bring up the performance, most importantly, can bring up the efficiency gain quite a bit. That include, as you all know this, including system photonic, silicon photonic, CPU, we talk about that later, and also the chip design company, they come out the standard for the chiplet. The other protocol side is the CXL. Right now we're talking about CXL 2.0 and PCI Gen 5. Next year coming up, PCI Gen 6 and the CXL 3.0 will further improve the disaggregation computing. And finally, all those implementing together, we will realize the DCI proposed by NTT, and that will dynamically allocate the power and also the resource for the computing. Okay? That for sure will increase the utilization and also the efficiency. Talking about the future chip design, there are a couple of things we have seen is a heterogeneous integration, different function of the chip, put it into the same die. Obviously, we need the standard. So TSMC in Taiwan leading the way, they do the standard. Once you can integrate different function, why not integrate the laser and the devices, make it become a CPO, co-packaged optical? There's a one rule of thumb maybe you should know. In a system, very powerful machine learning system, the rule of thumb is one system, you will need more than 10 conversion from the electric to the optical, and the optical back to the electric. So that means in a data center, you have 1,000 systems. You might have more than tens of thousands transceiver sitting there and doing the conversion job. And they consume power, and they also pay the penalty of latency. And they soon will hit the ceiling of the speed, 1.6 terabit per second or more. So co-packaging photonic network is must-have going forward. So photonic this is not new, right? Silicon photonics been talking 20 years at least, as I know, up and down. But only recent year, because of the AI-driven and also the ions pushing this technology, make it reality very soon in the industry. And once we have that, it will fundamentally change how we design the system, the racks. The racks level will push on to the data center level and also to the cloud level. And also the disaggregation and composable resources also can bring up to another level. And geographically dispersed infrastructure can be realized. Okay? Now, talking about the disaggregate composable computing, again, this is not new. Just because of the limitation of technology, we only can do at the system level in the past, or in the storage side. For example, you all know JBox, right? Just a bunch of disk. So that's an easy part to disaggregate. But now we need more. We need just a bunch of GPU, just a bunch of accelerator, just a bunch of flash, just a bunch of memory even. So that require a different architecture and the technology to support that. And for example, the photonic I just mentioned, and also the CXL protocol need to be there as well. So going forward, we can disaggregate the resource beyond the system, beyond the rack, and even data centers. Okay. And this is not dream. This is a very near future. We're seeing that. Okay, so once we have that, you must know one of the terms called collective computing. So if you have disaggregation on different data center, because right now you can see data center have its own strength and also limitation. To compensate each other's constraint, we need to do collaboration. Okay, but the collaboration require very, very low latency. Otherwise, the real-time application cannot be happened. So that's why, again, the photonic technology is the basis. Once we have that, we're going to do the orchestration and management. So that's why we have federation computing coming to the picture as well. Why we need to do that? Because the data center have its own rules and the self-governing, things. Who can ensure all those rules can be enforced, and the data privacy and the security can be ensured? So the federated computing come into the picture. Now, this is a very sophisticated and complicated situation. Most likely will be AI support managed the computing. Okay, so we talk about a lot of the new technology coming up. So the thing is that what's the future hold? I think we can predict very accurately for the next few years. Number one, exponential growth of AI data center for sure. No doubt about that. It will continue. And the cooling technology will, have some breakthrough. All photonic network will become reality to the world. Global AI networking, because of that, global AI network well formed and accessible AI to everybody. Just like today, you search online, it's for everyone. Decentralized data center will be happening. As I mentioned, each data center, each region have its own constraint and also the strength. So people can leverage the strength and then overcome the limitation. AI managed collaborative data center is also happening. Other than the technology and infrastructure, there's strategic location based on the geopolitical condition right? And some other factors. So after all, this is a national security issue, right? You see, any nation or even company, if they don't embrace AI or adopt AI earlier, they will lose their competitive edge very soon. Funny thing is that I give a speech in different country before, and always came out a question with AI take our job, right? So people concerning about that. I always tell them that let's not worry about AI, right? You probably need to worry about those people who use AI more than you do. They will take your job, right? So same as the nation or the company, same thing. So let's look at the blue part, which is technology and infrastructure. And you will see how IOWN is important in playing all those roles and bring this future to the reality. So lots of responsibility on the IOWN and lots of expectation on this global forum. So with that, I want to share some thoughts. It's just a kind of recommendation, right? And because we're new, so maybe it's not mature, please point it out. So IOWN is quite new, honestly speaking, but showing tremendous progress in the past couple of years. That was just amazing. But nobody can do it all. Right? So we got to have alliances, and then we come together and make this happen. Alliances like OCP, CXL, those association, is good to be aligned. And the second thing is that we need to develop the comprehensive ecosystem. And this is for transforming the concept or the standard we make become a reality, right? And the ecosystem, including from the upstream, the semiconductor company, system builder, solution provider, telecommunication carrier, operator, right? I believe we are doing that already. Just like a couple of months ago, the alliance with Chunghwa Telecom is a great example, and we're looking forward to more real-world application implement on this collaboration. Okay, and finally, I think we need to identify the right and the key application to tackle on, because this is a very fancy world. Right? And then lots of assignment going on. It's very easy to lose your focus. So what is the right application we should focus on? Maybe something most impactful and implementable and commercially viable type of things. Early this year, if I remember, IOWN actually demonstrated a great collaboration between two pianists. Right, so one of them in Tokyo, the other guy is in Osaka, and they play the same piece as a duo. Right, the latency is so small, just like on the stage, two person on the stage, maybe 20 meter away. That's all. Right, and so that's a great example to lay the foundation for the digital twin application. Right. On the business side, maybe perhaps we can identify some latency-sensitive application and do the collaboration among different company data centers and show how we can optimize the performance, drive the efficiency up, and also, most importantly, show the business innovation in the real-world scenario. I think that's quite important. So with that, I conclude my presentation. I hope this is helpful, and I thank you for listening. Thank you so much.
Thank you, Dr. Lun. Okay, we've now reached break time. We did get started a bit late, so we're going to break now and reconvene at 3:45. The IOWN technology exhibits are open during this break, but will also be open during the reception later today. You're welcome to download our exhibitor guide using the QR code on the screen. And otherwise, we will resume back here at 3:45 p.m. Thank you. All right, welcome back, everyone. You could please take your seats. We are going to get started again with the presentations. So please make your way back to your seat. We have about an hour and a half to go, and then we will be able to return to the exhibits. I also think we can start our live stream as well. I know we have online attendees joining from around the globe, so we don't want to keep them waiting much longer. So I think we're going to go ahead and get started. To welcome us back, I am going to hand it over to Robert Siu, Chief Marketing Officer at ITRI, to begin the introduction into our next presentation. Robert?
Ladies and gentlemen, good afternoon. 大家好。I'm going to use this time to briefly introduce my company, ITRI, Industrial Technology Research Institute. Okay. And I will, as a member, ITRI, how we align with the vision and mission of the IOWN. ITRI was founded in 1973. We are world-leading applied technology research institute. We are very successful in transforming Taiwan's industry from labor-intensive to innovation-driven. One of the big examples is ITRI has spun off over the decades with 6,000 engineers. We have spun off over 165 new venture companies, and one of them is TSMC. So what over the years, we have today our technology development spans across various domains, including semiconductors, information and semiconductors domains. And for semiconductors, we developed silicon photonic CPO for APN, all photonic network, as envisioned by IOWN. For computing domain, we developed composable, disaggregatable computing system as envisioned by IOWN. So we believe our technology development focus is pretty much aligned with the IOWN vision, mission, and roadmap. So in addition, we also working very hard to urge Taiwan's high-tech industry to align with IOWN, because we believe the alignment with IOWN is very important for the continued success of the high-tech industry of Taiwan in the world. So the next is my great honor to introduce the next speaker. We have been working at ITRI for a long time, and we familiar to each other. But however, I'd like to introduce him formally on the stage. Dr. Chair was the vice president of ITRI, my boss, okay, and general director ICL ITRI, and is currently the general director of Delta Electronic Research Center in Delta Electronics. And he is also a professor at the Tsinghua University at the Computer Science Department at National Tsinghua University at Hsinchu. He received his MSCE from Stanford University and a PhD from UC Berkeley. His expertise is in data center architecture and in management and AI systems. So ladies and gentlemen, please join me in welcoming Dr. Zhiga Jie.
Okay, thank you. Can we start? I have a presentation. Can we get it started somewhere? Point at the screen. Okay. Okay, so in addition to all optical network, I think you guys all know that resource disaggregation is also an important focus of IOWN. So today what I would like to talk about is the current status of memory resource pooling and the possible next steps. So we all know that there's such a notion called disaggregated rack. What does it really mean? Typically, a disaggregated rack consists of a bunch of servers. They are typically connected by PCIe network. That's the underlying technology. And then the resources in a disaggregated rack typically are organized into a set of resources. Like you can have a GPU pool, DRAM pool, SSD pool, or NIC pool. And with that, with all these resources in a rack are now organized into pools. Now, through software at the runtime, we can assign various amounts of different kinds of resources to each server. So if, for example, I want to organize a red server that has this much amount of GPU, DRAM, SSD, and NIC card, or a green server with a different amount of GPU, DRAM, SSD, and NIC card, and then yellow one, and so on. All right. So as you can see, with this technology, now we have this notion of software-defined server. Now, you probably heard this term before, software-defined server, but this is a true software-defined server in the sense that at the runtime, I can assign different amounts of hardware resources to a server. You don't really need to reboot or anything. At the runtime, you can assign now I need more memory, I need more GPU, I need more NIC card, I need more SSD, and so on. Through software at the runtime, you can reconfigure it. And that's the name of the game for software-defined server. Now, the underlying technology for disaggregation or software-defined server is a PCIe network. Now, as you know, the PCIe network was originally designed to connect peripheral devices within a machine to the machine's CPU. Typically, the PCIe devices in the machine are organized into so-called PCIe domain, which has a single master called the root complex, which typically corresponds to the CPU. So just remember, like in a machine, you have a PCIe network, you can connect a bunch of things together, and they form a PCIe domain, and they have a master called root complex, which is typically the CPU. So if you want to use PCIe to connect a bunch of machines and allow them to share their resources you have two major technical challenges. First, how do you enable the root complex in one PCIe domain, in one machine, to be able to access resources in another PCIe domain, another machine? So imagine today, if I have two machines, and one machine's CPU want to access the second machine's DRAM, can I do it today? No, you cannot do it today. And anything you want to do, you have to talk to the second machine's GPU in order to access the second machine's resource. But with this technology, we want it to be able to, for the first machine's CPU, to access the second machine's resource directly without going through the second machine's CPU. So the first challenge is you have to be able to do that, and through PCIe. And the second challenge is that once you allow multiple hosts to share resources, imagine that you have some resources that can be modified by all of them. Then how can you guarantee the so-called cache coherence, which I'll get to just in a moment. So we actually built a system called Laden that really enables resource pooling among multiple hosts over PCIe. So we connect a bunch of machines through PCIe, and indeed we allow one machine to access the second machine's resource directly without going through the second machine's CPU. And we can do it in a way that's secure, right? So it's not like you can actually do whatever you want and then screw up everything. And also the access is through native performance. So the Laden system that we built a couple of years ago indeed solved the first problem: how to enable one machine's CPU to access another machine's resource directly. Okay, that we solved. But PCIe, as it was defined, it lacked coherence support. So in this case, you can see that there are two pieces of memory. You have something called, on the top, you have main memory that's typically managed by the operating system. And on the low part, you have some memory that's owned by the accelerator, like GPU. They also own some memory. Now, for the upper part of main memory, the CPU can use a load and store instruction to access it, and you can cache them. But for accelerator, GPU, or NIC card, they can only access this main memory through so-called DMA. Right. For the lower part, the accelerator's memory, the CPU can also use a load and store instruction to access it, but it's uncacheable. Uncacheable is really bad because now it means that every time you access something, you have to go all the way to memory to get it. You cannot really access it through the cache. All right. So that's the one problem, that the CPU can still directly access the memory owned by the GPU, but those memory become uncacheable. All right. So that's a problem. Now, that is something that we tolerated in a long while, but in the world of heterogeneous computing, we cannot tolerate that anymore. What do we mean by heterogeneous computing? We are imagining a machine that consists of multiple computing units. And within it, you could have CPU, GPU, some FPGA computing unit, or some ASIC, and so on. So in that heterogeneous computing environment, that's what we want. We want also, like, the main memory and the memory owned by the accelerator, they can all be accessed by the CPU and the GPU through load and store instruction, and they can all be made cacheable. That's the main point. So we want all this memory within a machine to be able to access by various computing units, including CPU, GPU, ASIC, FPGA, and they are all cacheable. That's the vision. We want something like that. All right. And today, PCIe cannot give you that. That's the problem. All right. And that's one machine. But imagine that you have multiple machines like that, and each machine has different amount of memory, main memory, and the accelerator memory within that machine. And you want one machine to be able to access another machine directly, like I say in the first point. Then this becomes even more complicated. And how do you make them cache coherent? So that's one of the main challenge. And Compute Express Link was invented exactly to solve this problem, cache coherence. So just as a thought experiment, like I say, you have two machines. One machine has CPU, GPU, main memory, different kind of memory owned by GPU. Second machine also have CPU, GPU, and different amount of memory, main memory, and the GPU-owned memory. And imagine you want host 1's CPU to access host 2's GPU's memory, and you want CPU to be able to directly access it in a way that's cache coherent. How do you do that? That's the problem that CSLO tries to solve, all right? So I'm not going to bore you with the details, just to take my words of it. There are mechanisms that have been developed, like CSLO 1.0, 2.0, and now 3.0. And it consists of something like CSLO.IO, that more or less corresponds to PCIe, CSLO.cache, that's meant to maintain the cache coherence, and CSLO.memory, that's meant to support memory requests and response, and so on. And now you can have that picture. Multiple hosts. Each host has a different amount of memory. Some of them is main memory, some of them is GPU owned. And all this memory can be used as if it's a single pool. And they can be all accessed by different computing units in the machines. And they can be accessed in a way that's cache coherent, right? That's what CSLO promises to do. Are we there yet? Not exactly. Not exactly. But the standard is there, right? The standard already is defined, and then there are people trying to build various kinds of versions of the hardware. Now, with that thing, they actually define three types of CXL device. Type 1 is something like a NIC card, like your network interface controller. So it actually would cache some data and access memory, because when it receives some packet, it needs to forward it to memory. And type 2 is like accelerator, like GPU. So not only it can cache data, it itself also owns memory. All right? And type 3 is what we call memory expander. It contains nothing but memory. So it doesn't cache, it just mainly serve. Right? So when people want to access some part of it, send it some kind of request and you respond to it. So there are these three types, type 1, type 2, and type 3. So those are all standard. And like I say, CSLO is meant to achieve the grand vision that I just outlined, right? So now today, let's review. What do we have today? It's like October 2024. What do we have? Right now, we have CXL 2.0 compliant CPU from Intel and AMD. The latest version of CSLO, by the way, is CSLO 3.0, right? And then we have this PCIe switch that is compliant with the CSLO 2.0 from XCOM. And then we have this memory module, like those memory expander type 3 device coming from Samsung, Montage, SK, and so on. A bunch of companies are already providing this. But only type 3 CSLO devices exist. That's the main problem. Today, there are no type 1 or type 2 CSLO 2.0 devices. What does that mean? You don't see like NVIDIA or AMD produce GPU that is XCSLO 2.0 compliant. And you don't see Intel, the NIC card, that is CSLO 2.0 compliant. That's the problem, right? So that means that we can have a server and we can have a switch. The CPU is CSLO 2.0 compliant. We can have a PCI switch that's CSLO 2.0 compliant. We can even have type 3 memory expander that are CSLO 2.0, but I don't have NIC card. And I don't have CPU, that's CSLO 2.0 compliant. And when we don't have that kind of type 1 or type 2 CSLO 2.0 devices, what does it mean? I cannot put together a server that's really usable, right? Because these guys do not conform to CSLO 2.0. That means they don't support cache coherence. That's the problem, all right? So today, that's a missing piece, that we only have type 3 CSLO 2.0 device exists only. And it seems that a lot of these big guys like Microchip and Broadcom, their position is that they are going to skip CSLO 2.0 and go to CSLO 3.0 directly. It seems like their official position is like this, for good reason. Why? Because it's AI. Like they are all busy making money from AI. So CSLO is kind of low priority. That's the main reason. They can have various kind of reasons, but in my judgment, that's the main reason, all right? So what do we do with it? So suppose we really want to put together a CSLO 2.0 server, and we have all these components, except we don't have compliant NIC card or GPU. So the only thing we can do is we have to leverage software support to enforce cache coherence. Use the software. You cannot rely on hardware anymore. So I'm not going to bore you with the detail. Like, there's a way to do something like this. how we can actually pay attention to when certain transactions are happening. We have to make sure that doing a certain operation, like when you allocate something, you have to make them uncacheable or cacheable, or when you are done with a certain piece of memory, you have to evict it, explicitly kick them out of the cache, and so on. Various software techniques have existed to do that. It's pretty cumbersome and probably will incur certain performance overhead. But it enables you to build a CSL 2.0 server with a non-CSL 2.0 compliant NIC card and GPU. That's our judgment. Like the only way to do it is through some kind of software enforced cache coherence. So the next thing I want to talk about is actually if you look at this CSL 2.0 or the entire CSL trajectory, there's one missing piece, and I want to make that clear to this audience, so you know there is a limitation to that. So in the entire CSL discussion, they are all talking about something. When they talk about memory resource pooling, they are mainly talking about what we call centralized memory pooling. So what does that mean? It means that you can have a PCI switch sitting in the middle, and then you can plug in a bunch of what we call type 3 memory expander into it. That's fine. Just inject all this memory expander into the PCI switch, and then those DRAM modules now become available. They can be used as a pool by various servers on the left. So you can do that. So all the memory resources that are going to be shared are going to be centralized together in one place under that PCI switch. That's what we mean by centralized memory pooling. Remember that picture. That's what we have. What we want to do is distributed memory pooling. What we want originally, what I say is that you have a bunch of servers. Each server has its own main memory. And we want machine 1 to be able to use machine 2's main memory, right? That's what we want. So every machine already owns some memory, and typically now they have a gigantic amount of memory, 128 gigabyte, 256 gigabyte, half a terabyte, and so on. A huge amount of memory already exists in each of the machine. We want to make sure that the DRAM owned by each of the machine can also be used as a pool, right? That's what we want. So that's what we mean by distributed memory sharing, right? The memory owned by each of the machine can be aggregated together into a pool that can be used by any of the hosts in the same rack. That's what we want to do. Today's CSL doesn't support that. All right? So it only supports what I just say, like centralized memory pooling. It doesn't support distributed memory pooling. And of course, ultimately, what we really want is both distributed memory pooling as well as centralized memory pooling. All right, and so that's really the name of the game. Like being able to enable distributed memory pooling is a big step beyond what CSL can do today, and I think that's a very worthwhile direction to explore. So the next item I want to suggest as a possible next step is to add compression to it. Now, the idea of adding compression to memory module has been a long time. Since I was a graduate student, probably like 30 years ago, people are talking about this idea repeatedly. And over the years, repeatedly get shut down for various reasons, mainly because of latency. So the idea is very simple. If I have a memory module, if I somehow apply some kind of lossless compression transparently, so if you give me something like 256 gigabyte memory, and I can somehow use it as if it is 512 gigabyte, like twice the capacity, wouldn't it be really cool? Like being able to say that I can give you an effective capacity of 512 gigabyte, when in fact your physical memory is only 256 gigabyte. That's like really great, right? And it's no-brainer. Today, like if you do some analysis of the memory dump, it's really easy to get like a factor of 2 compression, lossless compression, without any problems. But how come this idea never takes off? The main problem is latency. So if you add this, and then every time you want to access something, and then the memory module need to decompress something and then give it back to you, it's too long. And then it affects the latency and affects the application performance. That's the main problem. And therefore, this idea, transparent, lossless compression embedded in DRAM module, never took off in the last 30 years. And now we think with this CSO, this idea may have another shot and may be able to make it this time. The reason is that for this like remote memory, the memory expander that I talked about, anyway, they are really remote, right? They are sitting somewhere in the PCI switch. So for a host to be able to access the memory in the memory expander, it's already a long latency. So just giving an idea, typically to access some local memory within the same machine, we are probably talking something about 100 to 120 nanosecond. But to access a remote memory in the memory expander, it's probably something like 400, 500 nanosecond, or 300 to 500 nanosecond. That means that there's already a longer latency compared to the local DRAM access. Because it's already somewhat longer, so maybe adding a decompression is not such a big deal. And that's the hope that we can do. So now there are sort of research and development projects. They are trying to revive the idea of adding lossless compression to this CSO-based memory module for this reason. So for example, suppose I want to build a 1 terabyte memory expander, right? You can build a 1 terabyte memory CXL memory expander using entirely DRAM. 1 terabyte of DRAM, pretty expensive. Or you can say, I only want to use 512 gigabyte of DRAM, and the other 512 I want to use SSD. So I can use 512 gigabytes of DRAM and 512 gigabytes of SSD. Together, it looks just like a 1 terabyte DRAM in terms of capacity and performance. If you can do that, then you are rich. Because you basically save a lot of money building this expensive memory expander. And the trick that you are going to use is, of course, this lossless compression technology. All right. And one additional idea of doing that is that sometimes you can say that, in this 512 gigabytes of DRAM, I further decompose into so-called uncompressed area and compressed area. So what do we mean? We mean that, for a small portion of the contents of the DRAM, we make them uncompressed. So whenever some accesses that want to go to that particular uncompressed area, it doesn't incur any decompression overhead. The response will be immediate. But if you want to access something that's not in the uncompressed area, but in the compressed area, now you have to pay the additional latency of decompressing them. That's true. But we are hoping that if you have a large amount of uncompressed area, the hit rate is going to be really, really high. So most of the time, you are going to hit the uncompressed area, and the latency will be exactly the same as if you don't use any compression, right? And why is that possible? So imagine that you use like in this configuration, we say that out of that 512 gigabyte of DRAM, I use 12 gigabyte for uncompressed area, and remaining 500 gigabyte for compressed area. So if whatever you want to access hit in the uncompressed cache, then the response will be immediate without incurring any decompression penalty, right? That's what I just said. And this 12 gigabyte is a huge number. It's a huge number. So we are thinking that can we really achieve something like 99.99% hit ratio, right? Like 10 to the minus 4 miss ratio, essentially. 99.99 hit ratio. So if you use 12 gigabyte to do that, and the answer is yes, you can definitely do that. That's not a problem. If you use 12 gigabyte as an uncompressed area, and then you take a typical server workload coming in, and whatever they are going to access, they are going to hit that uncompressed area with 99.99% probability. Okay. So of course, that's just some of the workload that we examine. But I'm sure that for some other workload, you probably have like worse behavior than that. But for most of the workload that we care about, probably this is a reasonable number to expect. So this idea, that eventually what it boils down to is following to the item that I listed as blue. What is the effective compression ratio you can get out of typical memory contents, right? If you examine your server and you examine the contents of your server's memory, like in a DRAM, you actually look at the contents of the DRAM in a server. How compressible are they? That's the first question. We are betting on you at least can get a factor of 2. Our number is typically between 2 to 5. Right? Depends on how lucky you are. Yes, typically 2 to 5. So a factor of 2 seems to be pretty modest objective, something that we can achieve. And the next thing is that can we hit the sort of the uncompressed cache area with a probability of 99.99. Here I just did 99.9 just to be conservative. But we want to go to something like 99.99% hit ratio. And I think this is a little bit challenging, but I think it's also through some clever replacement algorithm, prefetching algorithm, and so on, we think we have a good shot of achieving that. All right. So finally, this is my last slide. Like I say, I just want to report the current status of the memory resource pooling technology that we have today. And we all know that the current prevailing technology to make that happen is CXL. And the latest version commercially available is CXL 2.0. But only Type 3 devices exist. You don't have NIC card or GPU that are CXL 2.0. And you want to put together a server, you need to have a software-based cache coherence mechanism to make it work. That's the first observation. Second observation is that CXL, the entire enterprise CXL, only focus on centralized memory pooling, but we also need distributed memory pooling, as I explained. Finally, that it's probably a good time to revisit the idea of incorporating compression into the DRAM module, simply because CXL enables remote memory whose longer latency make it possible to rethink whether it is worthwhile to incorporate compression into the memory access path. Okay, thank you very much. This is all I have.
Thank you very much, Dr. Chu. Our next presentation is from Christian Uremovich, Senior Director, Solution Marketing at Infinera. Christian serves as an evangelist for Infinera's overall solutions, and today we'll discuss how the longer-term APN vision leverages optical functions.
Hello, everyone. Nice to see such a great audience, such a big audience too. It never was a good time to be in the optical industry like it is now. Optical transport networking in particular is becoming critical and important. That was not the case 20 years ago when I started in the optical industry. So it's really great. 3 things we are doing here, right? Reduce power consumption, increase capacity, and lower latency, right? So we will focus on this topic now. So next one is here. So let's look back 20 years ago when I started in the industry. We needed 15 watts per gigabit. So we had systems that needed 15 watts per gigabit and it was a full rack. 10 years later, we reduced it by the quarter amount. So we need now less. In the year 2010, we needed less power consumption. We went down to 4 watts per gigabit, still half a rack size. Today, we are actually already 100 times lower than back in 2010. Today, we do 400 gig capacity in 20 watts. That's 0.05 watts per gigabit, right? And we have no need to do transponders. We can put this pluggable interface that has in-band management, has control functions directly into the routers, okay? This is what's happening. So we are already there. We meet the goal of IOWN, reducing by 100 times. Thank you for your time. No, we are not there yet. We are not there yet. This is just optical transceiver technology, right? Okay, let's look. Are we stopping here? No, we do continue to improve our optical engines and transceiver technology. If you look at the time scale, every 3 to 4 years, we have a new technology coming out that gives us another 20 to 30% improvements in power consumption, better performance in terms of more capacity per wavelength, increased wavelength capacity, reach, lower footprint, lower power, and lower cost per bit. Now also coherent pluggables are on a journey. We today have 400 gig. Next year we have 800 gig coherent pluggables. 1.60 terabit is being working on. So we will continue improving performance, reducing power consumption, reducing footprint, improving latency. Okay, let me give you a more detailed example. So I hope this is not too complex. If you look on the top left, in the year 2019, we had 600 gig per wavelength. All this transponder technology comes in two wavelengths per module. So if you look at 2 times 600 gig running at 2 times 200 watts end to end, right? You have a transponder here, you have a transponder there. That gives me 400 watts divided by 1.2 terabit divided by 150 kilometer. That gives me, 2.5 watts per terabit per kilometer. Okay? With 800 gig technology, just a few years later, we can transport 600 gig wavelengths 2,500 kilometer. If I do the math now, 2 times 300 watts divided by 1.2 terabit divided by 2,500 kilometer, we are at 0.19 watts per terabit per kilometer. That's 90% reduction in power consumption. Wavelength capacity reach matters, okay? And then now our next technology is 1.2 terabit per wavelength. That's running at the same power consumption as our 800 gig technology. So that's now 5,500 kilometer. That's another 50% improvements if you can bridge the link of 5,500 kilometer, okay? So the journey is there. Optical interfaces are important. Optical interfaces reduces power. Technology is evolving. Same on the pluggables. So I will also be very quick here. 2017, we had 200 gig coherent pluggables. 2021, we have 400 gig coherent pluggables. Next year, we have 800 gig coherent pluggables. You see on the bottom how we increase the reach with every technology. And then also what we are increasing with 800 gig pluggables, it will be the first time that we have a Super C tunable 800 gig pluggable, more spectrum, and then also L-band version that we can go with the coherent pluggables into the L-band. Okay, so embedded optics, high-performance optics that we use in subsea and international networks. And then on the other side, you have pluggable technology that you use more in metro applications. There have been asked, is 800 gig coherent pluggable ready for long-haul deployments? And if you look at this chart, I don't have a laser here, do I? No, right? So if you look at this chart, 800 gig ZR plus DCO pluggable optics, you can transport 1,500 kilometer. And you can if you look at the data on the bottom, 800 gig pluggable is running at 30 watts. Our 800 gig embedded optical engine running at 150 watts. So I can reduce power consumption if I can use pluggables. However, 800 gig pluggables running on 16 QAM, the capacity that you can provide is limited to 25.6 terabit. With 800 gig embedded that runs at 150 watts, I have 64 QAM modulation, I can run 40 terabits, almost twice as much of a capacity. Okay? Remember, power consumption is important, but also capacities. So there is a trade-off. Do you want the capacity? Is your fiber expensive? You go with embedded optical engines. If you want to lower power and you don't have long stretches and fiber is a lot available, you go with pluggables. Oh, there's more, too much. So I want to show you also that on the coherent evolution, we are hitting a plateau of spectral efficiency, how much bits I can put in a certain spectrum of a fiber, okay? So if you see here 800 gig running in 100 gigahertz, right? And then 1.6 terabit is running in 200 gigahertz. So I'm basically doubling the capacity per wavelength from 800 gig to 1.6 T, but I'm also doubling the spectrum. I need twice as much spectrum. So I am not gaining any spectral efficiency, okay? So I'm not gaining more capacity on the fiber with higher speed wavelengths because they all run at 64 QAM modulation. So we need to look elsewhere to increase the fiber capacity, Where do we look? We look on utilizing the fiber spectrum. This is nothing new. If you look back in the year 1995, we have increased the utilization of the C-band from 3.2 terahertz to 4 terahertz to 4.8 terahertz. Then we had coherent revolution, where we had 4 QAM, 16 QAM, 32 QAM, 64 QAM modulation. Once we hit 64 QAM modulation, the spectral efficiency, which is the red curve, is plateauing. You see the fiber capacity is plateauing, it's not growing. So we need now to take a next step and increase the spectrum utilization in the C-band. This is called Super C-band, and it's named after me. My name is Christian, I'm Super C, right? Super Christian. No, it's not. It's the C-band. Okay, so with C-band, with Super C-band, we are adding 25% more capacity onto the fiber. What do we need to support Super C? We need an amplifier that can amplify the 6.1 terahertz spectrum, and we need transponders that are tunable in the Super C-band. That is available today. We can do this today. Of course, you can go into the L-band. You see here, L-band is another. It will double the capacity if you go into the L-band on the fiber, but L-band requires additional amplifiers. It requires additional transponders, a lot more equipment. So you're needing more power consumption and real estate. And therefore, if we can delay the need to go into the L-band, the better it is, right? So we can actually, with Super C-band, we can delay the need to go into the L-band and save power. So Super C is adding a left and right of the spectrum in the C-band, additional spectrum, so that we can put more services to it. And you can see with Super C-band, the theoretical maximum capacity we can put on a fiber is 55.2 terabit. If you use Super C and Super L-band, we are reaching 100 terabit on a fiber. Is this enough? For today it is, actually. For the next few years it will be enough. But we need to continue further. Capacity is increasing at a very high pace. You see here where we are now. We can do 1.2 terabit wavelengths, 92 of them into a Super C and Super L band. The next step is parallelism. If you go with dual core fibers, multi-core fibers, we can double the capacity, right? So this is the next step, is the evolution in new fiber types. Hollow core fiber to reduce latency, or multi-core fiber to increase the capacity, okay? It's called SDM also. SDM is being used mostly in subsea applications where you're using multiple fiber pairs into a single core. So when we look how do we evolve further, there are actually 4 knobs that we can turn. One is higher baud rates. Higher baud rates gives me higher reach of my technology. I can go from 1,000 kilometer, I can go to 2,000 kilometer, to 3,000 kilometer. The higher the baud rate, the better the reach is. But it doesn't give me more spectrum, right? Because I'm needing more spectrum as per wavelength and the higher baud rate. If you need more fiber capacity, we need to go into the Super C and Super L band, which is a low-hanging fruit. We can do this today. And later, we need to expand into the L band and additional bands like the S band and even O band, okay? So this is where we can add additional wavelengths into the spectrum. But here we need amplifiers to become more commodity and lower cost. So this is the next evolution step. On the left side, you see the advanced features. We can utilize AI and machine learning to learn from nonlinear effects and improve our performance a little bit here and there. And then also the new fiber types that we just discussed the slide before, SDM type of fibers, multi-core fibers. This is giving us additional fiber capacity, okay? But what we're also seeing is that the benefits are decreasing. You see here how we are going from 10 gigabit interfaces to 800 gig interfaces today, 1.6 terabit in few years, right? So we are still growing, but my CMOS technology is declining. This is the black curve. So we have 7 nanometer technology, 5 nanometer technology, 3 nanometer technology, 2 nanometer technology. We are basically also plateauing in terms of CMOS node process. right? So I will not have future gains a lot. So therefore, we need to look elsewhere. We need to look further because the benefits are decreasing from generation to generation. So we need to look at network architectures. Can we do something different? And the previous talk is already addressing some of it. Supermicro did also show great improvements in power consumption savings with immersion cooling. And by the way, the immersion coolant is biodegradable. We have also looked into it. This is also an interesting technology. But we need to look elsewhere. One option, this is all about photonics, APN, right? So is doing optical aggregation, right? It's a subcarrier technology with XR optics, which is an open forum also in the meantime. So we have open XR optics forum where we can reduce the number of transceivers that are needed because I can do point-to-multipoint optics. So one brief sentence about this, because this is huge. If you look how the network is done, it's typically hubbed. You have a hub node and you have multiple leaf sides. So you have always typically point-to-point connectivity today with optical lasers in point-to-multipoint application. So if you have 5 sites at the enterprises, you need also 5 interfaces on your hub location, right? And if you have, so you need always n times 1 transceivers. So if you have one laser at the hub site that can talk to multiple endpoints, that's point-to-multipoint technology. This is about XR optics, point-to-multipoint technology. It can radically reduce the number of transceivers. By the way, we position this at Deutsche Telekom. I'm based in Germany. And we position this at Deutsche Telekom, and we won the Green Futures Award at Deutsche Telekom with this technology concept. Okay? So we also have seen Subitomo talking about it and others. So point-to-point optics, point-to-multipoint optics is also helping to change the way we build networks and therefore reduce further power consumption. Another option, of course, is the IP over DWDM. If you can use your coherent pluggables not in the transponder, if you use it directly in the switch, in the routers, right? This is also improving power consumption. Another technology that is not important for this forum maybe is the private line emulation. We can support TDM services over IP. Why is that helping? Because there are operators still out there who have a legacy network with TDM services they cannot put on an IP network. If you put TDM services over IP network, this doesn't work unless you have private line emulation technology. So there are vendors are starting with private line emulation. We also are looking into it. So this is another way to support legacy TDM services over IP. And it can totally reduce an optical transport OTN-based network layer from your network, right? So this is another huge impact that can be done. Of course, optics replacing electronics functions, the key theme of the IOWN Forum is further important as we move on, okay? With that, I hope you still have interest in optical transport technology. I'm excited, and I hope we are all on the journey to reduce power consumption, improve capacities, and lower the latency. Thank you very much.
Thank you very much, Christian. There are a few extra slides. No worries, there for reference. Now we can go into our panel session. So as has been mentioned, the IOWN Global Forum has recently published 3 use cases. We will have representatives for each use case coming to the stage now. And the panel will be moderated again by Dr. Gonzalo Camarillo, our MSc chair.
That's like happening for him, so go ahead. Yeah, so we kind of see we now. No, they do work. So I could go make lessons. You would be something in probably you were there that.
there was this certain sound.
Hey, please have a seat. Good.
You okay? And then if you have a presentation, I will pass you the clicker, or better, even you tell me next slide, and I will be driving it because everybody seems to have having problems with the clicker today. So we're gonna be running this panel as we mentioned before, and you have seen in all the presentations throughout this session. Use cases are key to how IOWN Global Forum works. This is where we actually get requirements, and this is how we define our technology concepts, architectures, and technologies. So here we have a panel. I'm very happy that we managed to basically have a great lineup of experts that they're going to talk about 3 use cases, and I think you're going to find it extremely interesting. In particular, we're going to be exploring what pain points we are addressing from IOWN Global Forum. The idea, as I said before, is to have subject matter experts in different verticals, that they understand the pain points the industry is facing, or that industry vertical in particular, and how IOWN technologies are helping them address those and basically improve their services as a result. So first of all, I will have all of you give a small presentation, introduction to your use cases. So let's go in the order of the slide. So we will start with the remote media production for broadcast industry use case. So that would be Kuno-san. Yeah. Does it work? Okay. Yeah, perfect. So you just tell me next slide, and I will. Or you prefer to drive it? Yes. Or you prefer to? You want to go to the podium? Okay, then. Yes, that works as well.
So hello everyone, so my name is Hiroshi Kuno from Sony Corporation. So firstly, I'd like to briefly share the one of the 3 use cases that IOWN Global Forum is now focusing on. So this is a remote media production for a broadcast industry use case. So next slide. Yes. Oh, so good. Sorry. So this is a remote live media production use case. So in the IOWN Global Forum, we are discussing 3 use cases. So first one is a remote operation. This is a use case where the operators at a remote site monitor and control the media production resources from the remote site. That is to help to secure highly skilled operators that might be geographically dispersed. That is the first one use case. And the second one is a network sharing. So this is a network sharing use case. Typically, this is used where the media production is conducted between the event venue, such as the stadium, and the broadcast station. So in this case, wide area network is shared by multiple event venues and broadcast stations, and the network link is allocated on demand. So this provides a high quality connectivity and at an affordable cost by OpenVPN's dynamic optical path features. And third one is media production as a service. So media production resources such as production switcher, encoder, mixer, such equipment is installed in the data center, and their resources are allocated to the broadcast station on demand. So this provides a cost effectiveness and the scalability and accessibility in media production. This is 3 use cases being discussed in the IOWN Global Forum. So from next slide, so one was a key TV broadcast company presented some of the actual case.
Okay, thank you, Kuno-san. So I'm Yuki Katsumata from TBS Television. So we are one of the TV stations in Japan, and so we are the main target of this use case. So today I'm going to talk about our remote production. So at first, TBS Television is currently working on remote production over the internet using our enhanced transmission software Live Multi Studio. So today I'm going to show you two examples of our remote production. So first is World Athletic Championships in Oregon, USA. So in this case, we remotely control the on-site camera from Tokyo. So please look at this video.
Please click the video.
Okay. So this is second video. So would you please play first video?
Click the left one.
Yeah, that one.
Thank you.
Thank you.
So this shows that. So the left is in Tokyo. The right is on-site camera in Oregon. So we can control this camera remotely like this. So in this case, we control the on-site camera from Tokyo. In the second case, it's Masters Golf Tournament in Augusta, USA. So in this case, we remotely control the on-site video switcher from Tokyo. So please look at this video. Thank you. So this is Tokyo. So he's the operator. So he could switch the video sources with watching the multi-view video from the on-site video switcher. So you might be difficult to understand this situation, but this is Tokyo, and the multi-view was transmitted from the on-site video switcher. So he could control the on-site video switcher from Tokyo, like this. And thank you. So these transmitted video were for remote control purpose. On the other hand, so we transmitted high bitrate video for broadcasting using a dedicated network in both examples. Next page, please. Thank you. So, next page, I'm going to talk about challenges of remote production based on our experiences. So the first is network quality. So remote production is expected to improve the efficiency and flexibility of TV production. So however, it hasn't been widely adopted because transmitting video requires high-quality networks. And the second is delay. In remote production, if there is a delay, camera operators can't follow the player in real time, so making it challenging to produce high-quality video. So, and then we hope IOWN can solve these challenges. And as Kuno-san mentioned earlier, so if we could share the IOWN network with other broadcasters, so it'd be great to use it cost effectively. And so finally, so we are planning to demonstrate remote production with IOWN, using IOWN with NTT and Sony. It is November in Japan. So if you are interested in this demonstration, please feel free to join us. Thank you.
Thank you very much. Thank you, Kuno-san and Katsumata-san. Yeah, this is extremely interesting, this use case. We will get back to that later. Let's continue with another use case. Again, we're going to cover three. So the second one would be the service infrastructure for financial industry use case. And that would be Namba-san and Sasui-san. So you want me to drive the clicker? You'll do it from there. Okay. Thank you.
Yes, okay. Hello, my name is Masayoshi Namba from MFG. 20 minutes ago, I have changed my mind. So I have prepared some slides, but the first slide presents a perspective from the financial industry. which differ from those in telecommunication company or information process.
I think they are the wrong slides. Let me go until. Yeah, sorry.
Yeah. It differ from the telecommunication company or information processing company. To make this point easier to understand, I'd like to explain it using different words. I will cover the same content, but I will speak differently from what is on the first slide. So, if you can understand by just looking, feel free to zone out 5 minutes or something. I will explain the motivation behind IOWN in the telecommunication and information processing industry, focusing on what is uncontrollable, and what the limitations are. The uncontrollable factor for communication and information processing company is maybe the ever increasing demand of data. Because of this, I believe we are seeking solutions that are higher performance or more scalable. And the limitation, the fact that maybe infrastructure and the energy required for it cannot expand as quickly as the demand. In other words, it's slow. Please remember the uncontrollable factor is the demand for communication, so data amount, and the limitation is the speed at which physical infrastructure can be expanded. Now let me explain the financial industry. In the financial industry, the uncontrollable factor is what each customer is looking for today or looking for tomorrow. Another limitation is the service and the ICT facility required for them are unstoppable for us. In other words, customer needs are varied. Therefore, one of the expectations of IOWN for us is to be on demand, or in other words, have agility. Another need for IOWN is to provide service that do not make remote location feel distant. And the uncontrollable factor is, uncontrollable factor is not expansion of data, but the expansion of needs. And the amount of data is, for us, is actually manageable. IOWN is actually more powerful technology that I believe I can meet the expectation not only of the telecommunication industry, but also financial institutions. I mentioned, so there is gap. So our job at MFG and NTT Data is to bridge the gap and connect the technology with what we aim to achieve. And so in the next slide, I will introduce the specific initiatives we are currently working on. Sorry. This is first use case documentation. So it's in the case of intro region use case. It's a proactive scenario. So you can see that cloud lift shift to leverage the flexibility to the cloud and application or database separation to utilize ICT resource flexibility. It's the first case of we are now coping with. And Yes, and the second one is inter-region case. We have 2 or 3 data centers in general for disaster recovery, but it's very the 2D disease is it's very long distance in location. So we try to copy the database or the virtual machine for disaster robustness. Okay, that's all. Thank you.
Sorry.
Oh, I see. The bank plans they create. Yeah, exactly.
So yeah, I was swapping the order, so sorry about the confusion. So now we're gonna go with the, and thanks for the presentation. That was extremely useful about the financial services use case, which we've been discussing since the beginning of the forum. Now let's move with the third use case, which is the green computing using remote GPU. So please go ahead.
Okay. Thank you, Gonzo-san. Hello, I'm Tao Kajimoto from NetApp, data storage vendor. So I introduced a use case for green computing and remote GPU. So as almost you already know, developing AI model, enhancing company value requires a bunch of number of GPU cluster, and which providing excellent computing power. However, it requires power consumption and generated high heat density. So on the situation is green computing and green data center having a green power and water cooling ecosystem is central for the AI developing infrastructure to operating efficiently for the GPU cluster. So this is a right diagram on the slide. It is explained to the common AI platform design. So normally is a user solve and place training data right next to the storage, GPU storage on green data center. So for this design have several problems involved. First one is it takes a data transferring of time, transferring of time, and it also requires low latency and high bandwidth. And the second one is limited data center rack space on green data center. As I mentioned, green data center, there are a bunch of the GPU cluster, and it's not enough for the space for the storage, which is solving is training data. And the third one is handling sensitive data. It's I guess many company, almost company, having a complex security policy to passing data outside your office. On this issue, the answer is APN and the remote GPU. So the combination between the remote GPU and high-speed connection is between the GPU and the storage is key to remove these issues. Next slide. So these are three storage access methods between the GPU cluster and the storage. by using a remote GPUs. The first one is direct access. GPU server is access for the local data in customer office directory via APN. Second one is a cache, is only active data transfer for the storage on Green Data Center. And third one is a replication. All of the data is transferred and copying from client office to the GPU storage. So the three method is everyone is selectable for depending on the customer environment and targeting AI training situation. The high-speed connection between the GPU and the storage is enable customers to keep training an AI model to keeping the data on the office and not moving to all of the data for Green Data Center. It's like such as attach the GPU resource from Green Data Center to your office. So I think this is much for the currently trend AI development, such as individual LLM tuning using the customer office data. So I think it's AI development environment is more data-centric, releasing you from GPU-centric AI complex infrastructure. And next slide is finally, I explained to the NetApp, our company is a vision, named is AI Data Fabric. So our storage characterized by high speed, high performance, and high secure, and install the same OS on everywhere, including on-premise and hyperscale clouds such as GPU, AWS, and the Google Cloud. So is this NetApp future to combine the APN is we believe that we can provide a seamless AI infrastructure without customer concerning and not pay attention for the latency and difference from the location. So additionally, NetApp storage also have a lot of various security features, such as onboard anti-ransomware and personal information detection feature. It's happy to the keeping data as a security and for the handling sensitive data. That's all from my presentation. Thank you.
Thank you very much. Okay, so we are running a bit late, but I think we can take 10 or so minutes more to follow up with questions. But I would ask all the panelists to limit your answers to 1, maximum 2 minutes, so that we can basically wrap this up in around 10 minutes. So thank you. We saw the 3 use cases. As we said before, these are early adoption use cases, so they are the ones in focus for the IOWN Global Forum. They are the most important use cases at this point, so I was very happy with the introductions. Let me follow up. Let's start with Kuno-san. So you mentioned driving cost efficiency is very important for the broadcast industry. Can you explain how IOWN technologies are helping you address that?
Yes. So Katsuma-san presented. So currently, by using the existing network, so remote production has an issue for the delay, network delay, and the bandwidth. So in order to address such issues, OpenAPN could be utilized. That is the one point.
Excellent. Thank you. Thank you, Kuno-san. Yeah, it's good to understand that we can address real problems and pain points, as I said before, you are experiencing. Thank you, Kuno-san again. So, Katsumata-san, from your point of view as a broadcasting company, which additional benefits you see coming from using IOWN technologies?
Okay, so first, as I explained, we would like to use IOWN in remote production. So because our working style hasn't changed, so we have to change our working style so to keep up with the times. So and the remote production, I think remote production might be one solution to this, and we can reduce the cost of TV production, and so we can work flexibly. So we hope I looking forward to using IOWN in remote production.
Excellent. Thank you, Katsumata-san. Thank you. No, when I was reading originally the use case that you've been discussing for video production, I thought that was extremely interesting because, as I explained in my presentation before, it goes differently than other use cases. So I think it's a great use of IOWN technologies in a peculiar way or in a particular way. So that's extremely interesting. Thank you both. So moving on to the other use cases. So for Namba-san and Yasui-san, what are the benefits you see from using APN in particular in the financial institutions, maybe especially for reliability through disaster recovery situations?
Yes, we invest to the ICT facility for stability or continuity. So many double infrastructure or triple infrastructure for disaster recovery. So we at first we make it the more slim, maybe, and the cost reduction is the amount of cost reduction. We change the investment for new service or new investment of something new technology. It's better for our customer also. So I think the IOWN can make the ICT facility to slim and more efficient, I think.
Yeah, thank you. Something to add from your end?
Yes, thank you. So I think that APN is very important to make our data centers to up the resilience. So we have a data center in Tokyo and Osaka. It's apart from the 700 kilometers. But so when it comes to the disaster, so we cannot deficit any kind of one bit of the customer's data as well. So it's very important to make light speed replications to Tokyo and Osaka. It's a benefit of APN, I think.
Thank you again, Namba-san and Yasui-san. Again, the financial institutions use case has been basically discussed from the beginning of the forum, as far as I can tell, and is really interesting. For prospective members, all of you who may be interested in joining the forum, our next workshop will be in January 2025, and it will be in London. As I mentioned before, London is the financial capital of Europe, or one of them. So it's going to be great also to basically push this use case and talk with other financial institutions so that, again, our goal is to get basically to global deployment, to achieve global deployment. So I think involving financial institutions in other regions as well, it will be an extremely useful exercise. So, looking forward to that in January. Thank you very much. And now going to our last use case, which absolutely, AI, everybody's talking about AI nowadays. It's probably the most hyped technology. And so I'm very happy that we have a use case about that, which we put together, some time ago. So we have had time to develop it. So I would be curious to understand, which generative AI applications, you have seen that there's more demand for, and how is IOWN helping you in terms of, reduced training time, power consumption, etc.?
The most thing is I see is a really different point from current AI development infrastructure is if I utilize IOWN vision as a data centric. It means customer data from office is as on demand using for the remote GPU, such as GPU as a service. However, currently, its main use case is all of a customer copy store data next really near the GPU server, and for it is customer taking a lot of time to the management in their complex AI infrastructure, and the not focusing is a major job as improving and deploying an AI model. However, I believe IOWN is released this complex job from customer, and taking much their time to just focusing is as a top priority AI development. So I believe it is API in the future.
Very interesting. Thank you, Kakimoto-san. Thank you very much. Okay, so very unfortunately, we are running out of time, and we are running behind schedule, not because of this panel, but because of previous speakers. So very unfortunately, we cannot continue the discussions. I think this is extremely interesting. And as I said before, I think this is one of the keys from our forum, to have user companies like you setting use cases, explaining requirements, describing pain points, and understanding how IOWN can help addressing those pain points so that we can basically have an infrastructure that meets those requirements. So I think this was a great panel. Thanks again for helping, wrapping up in 10 minutes. Please, a round of applause for the panelists. And with that, I pass the floor back to our MC. Thank you, Patty.
Thank you, Gonzalo. Thank you to all the panelists, not only for your discussion points today, but also developing those use cases, which they are available, all posted on the IOWN Global Forum website. So if you have not already, highly suggest taking a look at those. Okay, as Gonzalo noted, we are running a bit behind time. So luckily, I can hand it over now to Mr. Tiansar Su, Changhua Telecom's president of the Telecommunication Laboratories, to close us out.
Thank you. Ladies and gentlemen, distinguished guests and esteemed colleagues, as we conclude this conference, Futures Taipei 2024, I would like to reflect on the tremendous insights, inspiring dialogues, and the remarkable achievements of the IOWN Global Forum being shared here. We explore the potential of the IOWN vision to redefine connectivity, expand our digital horizons, and build a smarter world. We have group leaders of the IOWN Global Forum talk about IOWN's viability, demonstrated by recent use cases and proof of concept. Moreover, we have Dr. Neng from Supermicro discussing the challenges and opportunities for IOWN in AI-driven data centers, and Dr. Che from Delta and Mr. Urimovic from Infinera, who shared why CXL and APN are key technologies for efficient memory sharing and increased fiber capacity. The key takeaways from this conference are: number one, IOWN's transformative power. We have seen firsthand how IOWN can address critical challenges in areas like data center infrastructure, AI, and network efficiency. Number two, related industry applications. The forum's recent use cases demonstrate the wide-ranging potential of IOWN technology across various sectors. Number three, technical advancements, in particular of CXL and APN. The presentations highlight the ongoing innovation and developments in IOWN-related technologies. Number 4, we should continue to collaborate and drive the adoption of IOWN technology. By working together, we can unlock its full potential and create a brighter future for all. Let's continue the conversations we have started here, deepen our established partnerships, and push the boundaries of what we believe is possible. In closing, I would like to thank our speakers, panelists, and participants for sharing your invaluable expertise and innovation. A special thank you to our organizers, as well as local partners such as ITRI, CIAT, PIDA, and III, who have infused so much energy into preparing these events. I also greatly appreciate the IOWN Global Forum for bringing this event to Taipei. As we know, Taiwan plays a strategic role in the supply chain of many key technological domains. Therefore, I look forward to more innovations and partnerships emerging from these inspiring events, and I hope to see more of you join the IOWN Global Forum soon. Thank you all for your participation. Thank you.
Thank you. I think really there is nothing more to say to conclude our presentation part of the afternoon. And now we get to go into our reception part of the evening. To start us off with that, I'm going to invite Gonzalo back to the stage for a toast and invite all of you attendees to please head to the back of the room, grab a drink from either the past drinks or the bar, and then come back for a toast, and that will start us off. And then we can go out into the exhibits, enjoy the food, enjoy the networking, and continue the discussion. So please grab a drink and return.